So that's a very good question. Usually the way we organize the mission at ESA is that we have basically two phases. We have first the development phases and then the operations. The mission manager takes over the missions after the commissioning phase, so is responsible of the mission during the operation. So basically it ensures that the mission delivers what it should deliver and make sure that the mission evolves, and that's important in the Copernicus framework, evolve with the user needs, because we have missions that have a very long time frame, 20 years in front of us, so the mission can't be static and needs to evolve in time. So the mission manager also oversees the overall operations, either of the space and the ground segment, and also is the main interface towards the users and the stakeholders, which makes these positions a very, let's say, important position because of the fact of the number of interfaces that you have. You talk with different peoples across the different ESA establishments, but also people outside ESA, including politicians or users, scientists, engineers. So that's really something that I like in this position. Sentinel-1 is a constellation of two satellites, Sentinel-1A and 1B. 1A launched in 2014 and 1B 2 years after. That provides continuity in measurements for almost a decade. What happens with Sentinel-1B just illustrates that space is a risky business. Despite all the efforts that we place in developing robust design, robust spacecraft, we have lost Sentinel-1B 2 years before its nominal lifetime. So of course, it poses a major problem for ESA, but also for the users that in some cases have lost the data that they were receiving from Sentinel-1B. In terms of challenges, this is, as I mentioned, a big challenge for ESA, and that goes much beyond the simple mission manager. But as my role as a mission manager was to organize the work in different fronts, because first you have to organize with all the different teams in ESA the investigations in order to try to recover first from the anomaly, which in that case wasn't possible. In a second work of actions, line of action was basically to work on mitigation the loss of Sentinel-1B by using the resources, the remaining existing resource like Sentinel-1A. So that's the things that we can do in our own, but also leveraging on our international partners to see how they can help us with their own satellites, how they can help us, ESA, and our users in mitigating this aspect. Of course, last work that we put forward at ESA was to speed up or to prioritize the work in the development of Sentinel-1C to launch it as soon as possible. After the loss of Sentinel-1B, the ESA priority was to launch Sentinel-1C as soon as possible for two main reasons. First, because we wanted to recover the missing capacity in space, but the most important was because Sentinel-1A was close to reach its nominal lifetime, and over the last 2 years Sentinel-1A has shown signs of important degradation. So we have never been so close over the last 2 years to completely lose the mission. So Sentinel-1C in that respect brings to us the missing redundant capacity that we are waiting for a long time. It allows us to see the future with a new eye, and now waiting also for the launch of Sentinel-1D that will complete the replenishment of the constellation, and that will bring to ESA and to the user community the long-term perspective of the next decade, basically. So that's a very good question, and also a very difficult question to answer at the same time. This is because Sentinel-1 is a generic purpose mission, like many of the other Copernicus missions, meaning that it doesn't have a single user or single applications. The SAR, synthetic aperture radar, which is the main payload of Sentinel-1, has well-known specific characteristics, like its capacity to see through the clouds, or its capacity to see independently from the daylight, that makes it the sensor of choice for observing over specific areas like the polar areas or the equatorial belt, for example. Our main drivers today for operating, or our main users, are threefolds. We have all the applications related to the CIs, or tactical CIs, in order to help the ships navigating through these difficult icy conditions, or through the icebergs. We have the maritime surveillance. Our European seas have never been so safe since Sentinel-1 is flying. And we have also all the applications, or all the needs over Europe related to the monitoring of our environment, land use, and land cover, for example. Beyond the technical aspects of the SAR and so on that we have previously discussed, I think that people have to realize that this kind of missions is a human adventure. And me, as a mission manager, what I like the most is the fact that in my work I have to talk with different people, different interfaces, being people developing the spacecraft, our colleagues from STEC or industry, for example, people operating the spacecraft, our colleagues from the FOSS, or people operating the ground segments, the users, commercial services, public services, SMEs, stakeholders. I think that it requires the capacity to talk to everyone, to understand everyone, in order to make the mission evolve the way it needs, by the simple fact that our environment and our needs are evolving in time.